All right, sixth graders. Today we're doing volume of prisms. What they say the base is not always what it's sitting on, but are the two ends that look alike. I reiterate that because you're going to make that mistake if you really don't think about it. The base is the two ends that look alike. There are only two of them. For pi, we've done all this. It is probably good to remember it. Remember, it's pi r squared. So if they give us diameter, cut that in half and get 4 times 3.14, which is pi for number 2. Rectangle with a base length of 8 and a height of 12. To get the area for that, it is 12 times 8. So we have 96, and 4 times 3.14, which is 50.24. All right, problem of the day. Today we learned to estimate and find the volumes of the rectangular prisms and triangular prisms. So, a tissue box will be helpful with this. If we have any old Pink Floyd people out there, you can think of the triangular prism that is there that they shine the light through. That's what a triangular prism is. If you take a piece of paper and fold it into a triangle, you think of the two blank ends as the bases. That's something you can work with to show yourself this is what I'm dealing with. Okay? Volume. Volume is the number of cubic units needed to fill a space. So remember, area was like the was the square. How many squares will fit inside there? Well, volume's 3D. It's how many cubes will fit in there. And that means, therefore, it needs to be by feet cubed, inches cubed, centimeters cubed, meters cubed. All right? It takes 10 or 5 times 2 centimeters cubes to cover the bottom. So, look, to cover the bottom, the cubes, they're 3D. 5 times 2. Hey, that's how you find the area for a rectangle, which would be that bottom rectangle. Then, you take that times the height being 3, and 3 layers of 10 gives you 30. I really don't care that they show it this way, but I understand why they do. Okay? Volume is expressed in cubic units. So the volume of the prism is 5 centimeters times 2 centimeters times 3 centimeters, or 30 centimeters cubed. They have 1, 2, 3 centimeters. So instead of writing, 30 centimeters times centimeters times centimeters, we write 30 centimeters cubed. It's another way to do it. That's why we have the cubed. That is important. And the other thing you can notice, people say, we just take the 3 numbers times each other. Watch out if they throw another one in there. They can be tricky. And when we get to the triangles, you got to remember how to find the area of a triangle, or to throw you all off. Oh my. All right. So, to find the volume of the rectangular prism, I like to think, 2 bases. Well, what are the 2 bases? Well, the bottom and the top are the same. This side and this side are the same. This side and the back side are the same. So with rectangular prisms, it's not as important to know the bases, but when we come to triangular ones, you probably want to know them. So, you can pick any side as the base, or you can really just take length times width times height, and you'll have the volume. Not so hard. There's your length, width, and height. You multiply those numbers, and 3,718 inches cubed. The cube for a reason. All right, again here with another rectangular prism. Think of your tissue box. Height times width times length, or height times length times width. Just identify them. All right. We multiply. As long as you can multiply right, you're going to get that correct answer. All right. To find the volume of any prism, you can use the formula volume of the base times the height, where B is the area of the base. This B, people are going to be like, where did I get the B? What's the B? B is the area of the base. And H is the height. Now, it's important to know the bases. Do you see how here there's two ends, the two triangles, that are exactly the same? These rectangles that are on the sides that are connecting the two triangles, those are not the same. It doesn't matter that it's sitting on that flat rectangle. You have to look at the two that are exactly the same. That's the triangles. So, for this one, this is where we have to focus. Oh, let's focus on the area of a base. Then we'll take it times the height. This is where you have to start really realizing, oh, okay, area of base times height. Okay, if I do this, how do I find the area of a triangle? Height times base. There's something else. Hopefully you're screaming at the TV. Divide by 2. So, 1.3 times 3.9 divided by 2. That gets me the area of the triangle, which is the base. And then you take all that times 4. When you do that, you will have your answer. It is okay to cross out first before you multiply. That's fine. You can reduce, seeing, oh. That's just saying, oh, bottom has 2, top has 2. I reduce this by 2, reduce that by 2. Now 1.3 times 3.9 times 2, you'll have the answer. It is good to write out this first, though, so you don't forget you're dividing by 2 to find the area for the triangle. All right. So there it is. 1/2 times 1/2 multiplied by something, or dividing by 2 is the same thing. All right. 1/2 times 3.9 times 1.3 times 4. That's what we had. When we do the multiplication out, you get 10.14. All right. The base of a prisms are always two congruent, two that are the same, that are parallel. All right. So we look here. None of these sides, well actually all of these sides might be the same. They all might be 6.5, but we're looking for the two that are congruent. Triangle that's congruent to the other triangle in the back. That is the base, not what it's sitting on. All right. To find the area of a triangle, we do base times height. 7 times 6.5 divided by 2 times the height. The height is 6. All right. There's our problem that we have. Remember, I say divided by 2. They say multiply by 1/2. Let's go ahead and look at their formula. B, area of base. That's this. Times height. That's that. All right. So, there's 1/2 times your 6.5 times your 7. That's the same as this. Then times your height, which is 6. Okay? You throw those in there, you get 136.5. All right. Again, hopefully you're seeing the trend. Base. Height. Find the area of base. Take it times height. Oh, area of this base. Base times height. Oh. 1.6 is the base or the height of the triangle. Times 4.2. If it's an area of a triangle, we must divide by 2. Then when you've got all that done, you multiply by 7. I bet that's what they put out here. All right. There it is. They put the same thing we put when they do their multiplication. 23.52. All right. 23.52. Now you can multiply 1.2 times 4.2 times 7, then divide it all by 2. Or you can do 1.6 times 4.2, divide that by 2, and then multiply that by 7. Either way, you'll come out with the same answer. All right. Again, hopefully you're identifying the bases. The base, because it has two that are congruent. All right, so we get 4.5. That's the base of the triangle. times, height of triangle 9, divide by 2, and times 5, because 5 is the height. Let's see if we have the same thing. Now, for some of you that have been sleeping through the first half of this, but they have 1/2 times that. Okay, multiplying by 1/2 is the same as dividing by 2. Look, if we do this, make those fractions, I'd have 4.5 times 9 over 2 when I'd multiply the numerators and the denominators. It's the same thing. We just choose to show it a different way. Hopefully that woke some of you up. All right? It's 6:30 on Sunday. That's why I'm a little bit into the waking up. 101.25 feet cubed, because we have 1, 2, 3 sets of feet that we're multiplying together. That's why we get feet cubed. Okay. Now suppose a facial tissue company, they're making tissue boxes. All right, ships 16 cubic tissue boxes in each case. What are the possible dimensions for a case of tissue boxes? So we got to work backwards. Understand the problem. The answer will be a possible dimensions for a case of 16 cubic boxes. This be the answer. 16 cubic boxes. They gave us the volume. They're asking us for the dimensions of the tissue box. List the important information. There are 16 tissue boxes in a case. The boxes are cubic or square prisms. They're cubes. They're the same on all sides. So, let's make a plan. You can make models using cubes to find the possible dimensions for a case of 16 cubes. All right. So, 16 cubes together, we could have a box that's like that. That might not pack so well. Or we could have 2 sets of 8 by 8 next to each other. Or I could have a block of 4 by 4. Or I could have 2 by, I could have a block of 2 by 2 by 4. I think that might ship the easiest, but let's see. These are all possible dimensions of a 16 cubic tissue box thing. Each tissue box, they had the square ones, like you maybe put on top of a toilet, you pull out the top. All right, the square ones, you could put them together in all these different ways. You could have 1 by 16. You could have 4 by 1 by 4. You could have 2 by 1 by 8. You could have 2 by 2 by 4. All right, all those different ways. If you wrote any of those out, good answer. And, 16 times 1 times 1, comma, 8 times 2 times 1, comma, 4 times 4 times 1, comma, and 4 times 2 times 2. All right, now we look back. Each of those showed 16, so we knew we were correct. Now suppose a paper company ships 12 cubic boxes of envelopes. 12 cubic boxes. All right, each box is a cube. What are the possible dimensions? So they're looking at this. What ways can we shape this? Figure it out. The 12 is the answer, so now we have to think of different ways we can make up rectangular prisms that would be 12 cubes. All right, 12 cubes put together to make a rectangular prism. What are the different ways? All right, there are 12 envelope boxes in the case. The 12 boxes are cubes or squares. All right, let's make a plan. All right, make a model. All right, you can make models that look like this. 1 by 1, and then we can do 12 long. 1 times 1 times 12. That gets a volume of 12. We could do 1 deep by 3 high by 4. 1 by 3 by 4. That's 12. 1 by 2 by 6. That's 12. 2 by 2 by 3. That's 12. All these different ways to arrange it. I think this would probably be the most practical, but that may not be what they do. You never know. All right, so these are all the different ways. 12 by 1 by 1, that's that one. 6 by 2 by 1, that's that one. 4 times 3 times 1, that's that one. Or we could arrange the cubes in 3 times 2 times 2. We would have the blocks and we would set them up in class and we'd give you different ways so you could make these. Sorry that doesn't happen this year. All right, we look back, make sure what we're doing made sense. All those multiplied to get 12 and you got your answers. Volume, not too hard. The base is not what they sit on, but the two that are congruent. Important for triangular prisms.